Okay, so welcome back to my channel. So today we are going to discuss more about Maclaurin series. So first of all, let's look at the definition of the Maclaurin series. A Maclaurin series is a function that has expression series that gives the sum of derivatives of the function. Yeah. So yeah, that's the basic definition of it. We will look through the formula here. Given a function f of s, we have f of s is equal to the value of the function when x is equal to 0 plus the derivative of f when x is equal to 0 plus 1 factorial times x to the power of 1 plus the value of the second derivative of f when x is equal to 0 over 2 factorial times x squared and so on. And now we have the standard expression for some of the functions for the Maclaurin series, and I suggest you to better memorize these functions, or else yes, you can derive it, but I'm afraid that you may lose a bit of time by redoing this standard expression. Okay, so yeah, there are 4 of it. Yeah, so here it is. E is a natural number to the power of x is equal to 1 plus x squared over 2 factorial plus x to the power of 3 times over 3 factorial plus x to the power of 4 plus 4 factorial, and etc. etc. For this, sine x cosine and cosine x, this is quite similar. First, we have for sine x, we have x minus x to the third power of the over 3 factorial plus x to the fifth power over 5 factorial minus x to the 7th power over 7 factorial. Now we hope that you notice this signs is alternating. So here we have positive, negative, positive, negative, and positive. And for cosine x is the same. 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial, and I can continue over 1 over 6 factorial to the times x to the 6th power, and etc. Yes, so the signs are alternating, so you have to take some attention to it. And for 1 over 1 minus x, we have this beautiful expression, which is 1 plus x squared to the and plus x to the third power plus etc. Okay, so we now have an example here. So we want to find the Maclaurin series of ln of 1 over x. So first, what we need to do is to differentiate this function. So let me answer here. So now we have to let fx is equal to ln 1 plus x. Okay, now when we plug in x is equal to 0, we have is equal to ln of 1, which is 0. Now we shall differentiate it for the first time. So we have f prime of x. Okay, so the derivative of ln is 1 over 1 over 1 plus s times the derivative inside. So the derivative of 1 plus s is 1. So we just have to multiply by 1, which is just the same, which is 1 over s. 1 over 1 plus s. And now we shall plug in s equal to 0 into here. So now we have f prime of 0 is equal to 1. Now let's differentiate for the second time. Okay. Treat this as the following. This is equivalent to 1 plus s to the negative 1 power. So when we differentiate, now we have negative 1 times 1 over s to the power of negative 1 minus 1, which is negative 1 over 1 plus s to the power of negative 2. When we plug in, okay, so now we have the second derivative of f. So now when we plug in s equal to 0, now we have f double prime of 0 is 1 plus 0 is 1. 1 to the power of negative 2 is still 1. And so we have negative 1 here. Now let's differentiate it for the third time and the final time, I guess. Good. Now let's differentiate it. Now we have negative. Let's apply the product. The power rule again. Put the negative 2 down, and now we have 1 plus s to the negative 2 minus 1, which is 2 times 1 plus s of negative 3 to the power of negative 3. So now we have this expression. Now let's plug in 0 to the expression. So now we have f triple prime of 0 is equal to 1 plus 0 is 1 to the power of negative 3 is still 1. Now when we multiply by 2, now we get 2. So in general, yes, okay, so ln of 1 plus s is equal to f0 is here. Well, f of 0 is 0 plus now we have f prime of 0 over 1 factorial times s to the 1 power, s to the first power. So now we have f prime of 0 is 1 over 1 factorial times s to the first power. And now we have the double prime f double prime of 0, which is negative 1, over 2 factorial times s squared plus 2 over 3 factorial of s to the power of 3, and so on. Since we calculate it to the, so yeah, since we differentiate 3 times, so this is our limit. Yeah, you can feel free to differentiate more, but I will just limit here. And don't forget to add this sign, as this is very important. This is very important because Maclaurin series is another part of infinite series, so don't forget to add that. So in conclusion, now we have learned of 1 plus x is equal to 0. Yeah, I don't think we need to write it. And simplifying this, we have 1 and 1 times x, which is equal to x. And now we have negative half of x squared plus 2 over 3 factorial of x to the power of 3 plus so on and so on and so on. So this is how we do the Maclaurin series. Yes. So now we have all of this, and yeah, that's all.